Evaluate this triple integral where E is the region bounded by the planes, this plane and the coordinate planes. That means xy plane, yz and gx. We can in fact graph this plane 2x plus y equals 2x plus y plus c equals 2. Let's find 3 points on this plane. If we take y0, g0, okay, y0, g0, then 2x equals 2. That means x should be 1. So 1, 0, 0 is a point on the plane. Similarly, 0, if we take 0 and y equals 2. If we take x0, y0, then g equals 2. So these are the points. Here is 1, 0, 0, 0, 2, 0 on y-axis, 0, 0, 2 on g-axis. So this is the plane we are looking at and bounded by these 3 coordinate planes as well. Okay, that's the E part. And if we look at closely, it does not go below xy plane because we are talking about coordinate planes. So G has the lower bound of 0 and upper bound it can go up to this. We can find from here. Okay, so let me write the following. This triple integral as this is same as we'll have a region on xy plane. Okay, that's the projection of E on the xy plane, and inside now we have bounds for G, and this is 3g, we have dg. So we are writing this dv as dg, dx, dy, and we are saying just d for now at the area dA. And the lower bound for G is just xy plane, which is 0, and upper bound is found from here, from this plane. So if we solve for G, G equals 2 minus 2x minus y. Okay, so this will be 2 minus 2x minus y. Now let's find the projection of this onto xy plane. That's how we find D, x, y. So pretty much this line. On y we have 2, 1, 2. On the x we have 1, just 1 here. So this is the region D on the xy plane, this D. Okay, and the equation we have, since we have 2 points, we can find the slope, and y equals mx plus b. Or if we go up and look at the plane, take g0. If we take g0 here, this is 0, then what do we get? 2x plus y equals 2. That is same as y equals 2 minus 2x. So the equation for this line is y equals 2 minus 2x. Or we could have found just using these 2 points, 1, 0 and 0, 2, by using y equals mx plus b. And this region I can make like type 1, just going in this way, and x ranges from 0 to 1, and y goes from, this is y equals 0. X-axis means y equals 0, and this is y equals 2 minus 2x. So this one is, okay, inside we have g equals 0 to 2 minus 2x minus y, 3g dg. Now I'm writing x in the last, dy dx, and x has bounds from 0 to 1, and y has bounds, lower bound, that's the x-axis 0, upper is y equals 2 minus 2x. Okay, if we switch dx and dy, if you write dx dy, then y has bounds from 0 to 2. I mean that y would be outer, 0 to 2, and the x would have been, now we have to go horizontal line, so y-axis is x equals 0, and this one we need to solve this for x. That would have been y equals 2 minus 2x, 2x equals 2 minus y, so x is divided by 2, 1 minus half y. This would have been 1 minus half y, and do the same work, the final answer would be the same. But I want to go dy dx, okay, which is also known as type 1. So now we just evaluate this like calculus 1. So x has bounds from 0 to 1, y has bounds from 0 to 2 minus 2x. Now inside, let's integrate 3g. This is 3 times g square over 2, 3g square over 2, and we have bounds for g, that's 0 to 2 minus 2x minus y, and dy dx. X from 0 to 1, y from 0 to 2 minus 2x. 3 halves is constant, we don't have to worry about that. Replace g by this expression, that is squared, minus 0 is squared, so there is no contribution from the bottom, so that this is squared. 2 minus 2x minus y quantity squared, minus lower limit 0 is squared, not writing that, dy dx. Okay, now we can do this, don't have to. Now we want to integrate this function with respect to y. Okay, so that is x 0 to 1. Let's integrate. This 3 halves constant is just there, so this is squared, and we are doing with respect to y, so y is linear because y the negative 1, so it's like some constant, because 2 minus 2x, they behave like constant, some constant minus y squared, and when we integrate with respect to y, it's like u squared. You can go for u substitution, but the easiest would have been, since the derivative of this is negative 1 dy, we can just say c minus y from power rule, 3 divided by 3 times the coefficient of y, which is negative 1. Okay, so I'm going to use this fact. So this integral of this with respect to y is 2 minus 2x minus y, power rule, 2 plus 1 3, divided by 3, but the coefficient of y is negative 1, so we need to divide by that as well, negative 1, and dx. Okay, now we can cancel these two, and 2 negative 1, negative 2 we can pull all the way outside, negative 1/2, that is in fact 2 times negative 1, negative 2. And now let's integrate this cube in the same way. This will be 2 minus 2x minus y raised to 3 plus 1 4 divided by 4 times, we need to divide by the coefficient of x, which is negative 2. Okay, and we need to evaluate from where to where. Oh, I integrated by, I forgot to evaluate at 0, y equals 0 and y equals 2 minus 2x. That's a mistake, so I was going too fast. Here this part we can still cancel. Y from 0 to 2 minus 2x. So this 2 times negative 1, we can still pull negative 1/2 outside. X from 0 to 1. Let's replace y by 2 minus 2x, that's the upper limit, and y equals 0, lower limit. Okay, this is 2 minus 2x minus y is 2 minus 2x. So when we plug in 2 minus 2x, this is 0. 0 cube, just 0. Minus lower limit. Y equals 0, let's plug in 0 here. So 2 minus 2x cube. Okay, upper limit minus lower limit. And I put these constants on the front. So dx, let me simplify, okay. This is negative, in fact, negative and negative 1/2, just positive 1/2. X from 0 through 1. This is now 2 minus 2x cubed. Okay, so 1/2 we can pull all the way outside. let's integrate this with respect to x. So that's 2 minus 2x to the 4th power rule divided by 4 times the coefficient of x, which is -2. And we need to evaluate this from x equals 0 through 1. This 4 times -2, -8 times 2, -16. So -1 over 16. Then let's do upper limit, plug in 1 here. So 2 minus 2, 0 raised to 4, just 0. That's the upper limit part. Minus lower limit, plug in 0 for x. So 2 minus 0, just 2. 2 raised to 4 is 16. So we have -1 over 16 times -16, negative, positive. 16 is cancelled, so 1. Okay, final